Continuing on with part 2 of our review section, we're going to talk about quadratics, we're going to talk about polynomials, and then we'll talk about inequalities. So I want you to think back to when you first saw quadratics back in Algebra 1, or maybe with Mr. Murphy with Honors Algebra. The whole goal in a lot of these things is to make a picture of this. So if you can graph it, more power to you, because we want to be able to visualize these things. Where is it opening up? Where is it opening down? So let's just look at this question. It says sketch the graph y equals 3x squared plus x minus 2. So we already know that it opens up, and it opens up because we have a positive value in front of the x squared term. The y-intercept, if you plug in 0 for x, we would get the y-intercept to be 0, comma, negative 2. The y-intercept will always be this constant term at the end. So then the next thing that we would want to do is find the x-intercepts and the vertex. So I'm going to give a couple different ways, but let's first focus on the x-intercept. To find x-intercepts, that's where y is equal to 0. So we plug 0 in for y, 3x squared plus x minus 2. And this one is, we're looking for numbers that multiply to be negative 2 that add to positive 1. So the first term would be 3x and x, because that's the only way we can get 3x squared. So now we have to think, is it 2 here and 1 here, or is it 2 here, 1 here? So I'm just going to try. We're going to have negative 2 and positive 1. And now we're going to just check our work really quick. So we already know the first and the last terms work out, because negative 2 times 1 is negative 2. 3x times x is x squared. So if you remember FOIL, all you have to do is check the OI part in FOIL. So 3x times 1 is 3x, negative 2 times x. That gives me positive x, which is what we want. So that is my factored form. That's set equal to 0, so we set each of those factors equal to 0. Both equal to 0. Add 2, divide by 3, we get x equals 2/3. And then subtract 1, we get x equals negative 1. And I would prefer if you wrote those as ordered pairs. So that would be 2/3, comma 0, and negative 1, comma 0. Now the last thing, if you don't want to use completing the square, to find your vertex, we're going to label that h, comma k. It's just the standard form of what we use for a vertex of a conic section. In this case, it's a parabola. So we are going to say h equals negative b over 2a. And this is our a for x squared, b for our x term, and c is our constant. So h equals negative b over 2a. So h equals negative 1 over 2 times 3. So I get negative 1/6. And that is going to be my x value in my vertex. To find my k value, which is going to be our y value, I can either write y or I can write k. I have 3 times negative 1/6 squared plus negative 1/6 minus 2. So negative 1/6 squared is 136 times 3. That would be 1/12 minus 1/6 minus 2. Now, and if you wanted to do this, let's get everything to have a like term. So I have 1/12 minus 2/12 minus 24/12. That's negative 26 plus 1 is negative 25/12. That's my k value. So my vertex in this case is going to be negative 1/6, comma, negative 25/12, which is a little more than negative 2. So I'm going to mark these off. 1, 1, 2, 2, 1, 2, and a little more. So if I graph this, I have my y-intercept, let's start with that first, is negative 2. I have my vertex at negative 1/6, negative 25/12. So I'm going to label that V. I have my x-intercept at negative 1. I have my other x-intercept at 2/3. Let's see if I wrote that. Yep, 2/3. So that would be there. If I graphed everything correctly, and I said it opens up, we go down, and then back up. And then we put our arrows on our function. So that is a quick refresher on graphing quadratics. Let's get a little more about specifics about quadratics. Usually when it comes to those, we're talking about factoring. So one thing you might see is if we have a polynomial that has a variable in all three terms, we first want to see if we can factor out the GCF. So I would ask you, if this was class, what's the GCF between x cubed, 5x squared, and 6x? We obviously see that it's an x. Then we have x squared plus 5x plus 6. Now, if we are factoring this completely, then I want to say this is x. Numbers that multiply to 6 that add to 5 would be x plus 3 and x plus 2. That answer is completely factored. Difference of squares factored to conjugate pairs. Conjugate pairs would be the same thing, opposite signs. Numbers that 81 is a square, so we have 9 and -9. These things come up all the time, so know your squares and your cubes. Next up is the sum or difference of cubes. Now we're looking for the formula, so sum would be a cubed plus b cubed, and difference would be a cubed minus b cubed. And if you had Mr. Murphy at all 8th grade or freshman year, you'll remember his rhyme. So I'm just going to say it to you, but if you want to say it along with me, feel free to. First, write it without the cube. So instead of a cubed and b cubed, we have a plus b. Then square the first term, a squared. Opposite sign, product of the two. Add the square. So we have a squared minus ab plus b squared. Likewise, if we have the difference, first write it without the cube. So the subtraction sign stays. Square the first term, a squared. Opposite sign, so instead of a minus, we have a plus. Product of the two, add the square. And last bit is factoring by grouping. And this is where, if we have 4 terms, generally we're looking for the GCF and then the GCF again. So if we have y squared plus xy, we have a y in common with both of those terms. Then we leave it. What's the GCF between 3x and 6y? Well, that's a 3. So we're left with x plus, oops, I'm going to restart this. Forgot that there is a typo in this problem. There is a 2y in front of that. Now let's see if we can do this problem. I'm going to just change the color for fun. So GCF between 2y squared and xy would be a y still. So we're left with 2y plus x. I apologize for that printing mistake. GCF between 3x and 6y would be 3. And we're left with x plus 2y. Now the trick with these is that once we see we have our GCF from those two terms, these two are the GCF between these two terms. So I pull out the 2y plus x, and what I'm left with is the y and the positive 3. And that is factoring by grouping. If you're solving a quadratic, there's 2 ways to do this. I'm sorry, 2 steps to doing this. We set to standard form. Then we're going to factor from that. If you want to remember, standard form is ax squared plus bx plus c. Then we set each factor to 0 and solve. So let's try a couple. That's if you can factor. What happens if you can't factor? And this is our quadratic formula. So the way I always remember it is I say it every single time. So quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. Now we have our a term, which is the coefficient in front of the x squared, the b, which is the number in front of the x, and our c is our constant term. We're solving for x-intercepts. So we take the opposite of b, so negative 12, plus or minus the square root, 12 squared, minus 4 times 4 times 3, all over 2 times 4. Now 4 times 4 times 3, 4 times 4 is 16. 16 times 3 is 48, so we're just going to write minus 48. We're going to subtract 144 minus 48, and we get 96. So we get x equals negative 12 plus or minus the square root of 96 all over 8. Simplifying 96, I've got 96 is 16 times 6. You can check my work on that. So we're left with negative 12 plus or minus 4 square root 6 all over 8 equals. Everything is divisible by 4, so we have our final answer of negative 3 plus or minus the square root of 6 all over 2. That is our friendly quadratic formula. Next up, if you remember chapter 4 from pre-calculus, this is where you talk about synthetic division and long division. Just like you can divide numbers, we can divide polynomials. So what we're going to do is say find the remainder in the division problem, x to the 5th minus 4x to the 4th plus x cubed minus 7x plus 1 by x plus 2. We're going to show both ways. We have synthetic, and then we have just a line here, long division. If you remember synthetic division, we take our factor, which is x plus 2, and we take the 0, which is negative 2. And then we make our little box, and we are going to write our coefficients in descending terms. So I have 1 x to the 5th, negative 4 x to the 4th, 1 x cubed, 0 x squared, negative 7x, so negative 7, should not write the x, and then plus 1, or just 1. This is the most missed concept. And it's just like the same idea as place value. If you had 10,000 and let's say $15 in your bank account, that is not the same as 115, is it? We don't negate the zeros. We have to maintain the place value there, which is what happens here. Okay, so once we have the coefficients, this is a relatively simple process. So we bring down the 1, multiply negative 2 times 1, negative 2. We write that under the next term, and then we add. I'm going to do this in yellow, orange. And I get negative 6, negative 2 times negative 6 is 12, add 13, negative 26, add negative 26, multiply positive 52. Positive 52 take away is 45. 45 times negative 2 is negative 90. Add 1, I get negative 89. So this problem, this quotient, our remainder is, let's get this in a slightly easier color to read. Everything is 1 degree less. And this works, if you forgot, synthetic division only works when we have a linear binomial divisor. Our answer would be, we started with x to the 5th, so now this is x to the 4th minus 6x cubed plus 13x squared minus 26x plus 45 minus 89 over our divisor, x plus 2. If you want to see the long division version of this, we write the divisor on the outside. We write our dividend on the inside, x to the 5th minus 4x to the 4th plus x cubed plus 0x squared minus 7x plus 1. Okay, I'm going to go a little fast because we'll get the exact same answer. The process goes as follows. X times something gives me x to the fifth. That would be x to the fourth. Now we multiply and add. X to the fourth times x, x to the fifth, x to the fourth times 2, plus 2x to the fourth. Then we subtract both terms. The x to the fifths go away. I'm left with negative 6x to the fourth. We do the same thing. X times what gives me negative 6x to the fourth? Negative 6x cubed. Multiply both of these. Negative 6x 2 times negative 6x cubed would be plus 12x cubed. Then I subtract these. So if I subtract, I change all the signs. And now I add these two, and I get, let's just bring this term down. Sorry, that should be 13x cubed. And this process follows. I would like you to finish this division problem out before you move on. We're going to stop the video here, finish this problem up, check your answer, and then we will move on to the last two to finish up polynomials and rational functions.